B. Okay, these are very simple problems. Let's try one more problem. A 0.2 kilogram stone attached to a 0.8 meter long string is rotated in the horizontal plane. The string makes an angle of 20 degrees with the horizontal. Determine the speed of the stone. Now, what is the meaning that a stone tied to a string is rotated in a horizontal plane? Let me see if I can show that to you. Now, in place of the stone, I have the metal ball, and this is the length of that string. And you can see it is made to go around a circle in a horizontal plane. This is what the problem says. Now, at any instant, let's stop this at any given instant here, for example. That means the string is now inclined at an angle with the vertical. If this is the vertical, when the string is like this, it has a certain angle at any given time. Is that right? Yes. Now, if the speed is increased, that angle will increase. See what happens? I'm increasing the speed, that angle is changing. Angle is increasing, if you notice that. So, if I decrease the speed, I'm decreasing the speed, and the angle is decreasing. So, what is it that we need to find? Well, we need to find determine the speed of the stone when the angle is 20 degrees. The string makes an angle of 20 degrees with the horizontal, and determine its speed. In other words, when the string makes an angle of 20 degrees with the vertical, what is its speed? Alright, let's see how we can set it up. Now, I have drawn two diagrams here. This one is the stone going in a circle. Remember that horizontal circle? And this is the vertical position. And this is the position at any given time. And the angle given to us, what is the 20 degrees? 20 degrees with the horizontal, not with the vertical. This is 20 degrees. Now, if that angle is 20 degrees, what will be this angle? If I draw a line from the center to the stone, remember that will be at right angles to this line. You must understand that if this is the vertical position and the stone is over here now, this distance is, well, when this is at right angles, I have that diagram here, then that angle will be 20 degrees. There you are. Okay. So the length of the string is 0.8 meter. So this is the length of the string, which is the same as this, which is 0.8 meter. Theta is 20 degrees. The angle made by the string with the horizontal is 20 degrees. Now, what I have drawn, this triangle is, this is the vertical, this is the length of the string, and I drew the line perpendicular here. See, a line drawn perpendicular from the position of the stone to the vertical, and it is that line. And let me draw that over here. It is this line that I have drawn there, and that angle will be 20 degrees. So you can see that angle and this angle are the same. It is this triangle that I have drawn here. And let's see, the mass of the stone is 0.2 kilogram. the radius r of the circle. What is the radius r of the circle? This is the radius r of the circle. The radius r of the circle can be written in terms of this length L. If you look at this triangle, you know that cosine of 20 degrees is adjacent side divided by hypotenuse. Therefore, this adjacent side, which is the radius, equal to the hypotenuse times cos 20 degrees. So we can write r equal to L cos 20 degrees, and that is 0.75 meter. The radius of the circle, the horizontal circle, is 0.75 meter. Now, the tension on the string T has a vertical component. You can see the force when the pendulum goes round. The tension on the string is directed like this. It has a vertical component and a horizontal component. Now, it is the horizontal component that supplies the centripetal force. In order to keep that stone in a circle, going around a circle, you need the centripetal force. Now, where is the centripetal force going to come from? The centripetal force is actually provided by the horizontal component of this. Now, if you look at this, this angle will be 20 degrees. Therefore, well, no, that angle won't be 20 degrees. We already said it is this angle that will be 20 degrees, which is this. So if this angle is 20 degrees, this will be 20 degrees. And therefore, the component towards the center, the horizontal component, will be T times cos 20 degrees. And the vertical component will be T times sine 20 degrees. And it is this component that provides the centripetal force to keep that stone in circular motion. Okay. So T sine 20 degrees, what does that do? What is the function of that T sine 20 degrees? This T sine 20 degrees balances the weight of the stone. So we have T sine 20 degrees equal to mg, the weight of the stone, which is 1.96. So we have one equation, T sine 20 degrees equal to 1.96. What about this? The T cos 20 degrees provides the centripetal force, and the centripetal force is mv squared over r. So T cos 20 degrees is mv squared over r, but m equal to 0.2 kilogram, the radius equal to 0.75 meter. Therefore, T cos 20 degrees is 0.2 v squared divided by 0.75. Now, if you divide the first equation by the second equation, what does that give you? Divide 1 by 2. T sine 20 divided by T cos 20. What does that give you? T sine 20 divided by T cos 20. The T's will cancel. That will give you sine 20 divided by cos 20 is tan 20. And on the right side of the first equation is 1.96. The right side of the second equation is 0.2 v squared over 0.75. And let me do that for you. So what I have done there is the left hand side of the first equation is T sine 20 degrees equal to 1.96 is the first equation. T cos 20 degrees is 0.2 v squared over 0.75 is the second equation. Divide the left hand side of the first equation by the left hand side of the second equation. Divide the right hand side by the right hand side. Now there t and t goes. Sine 20 divided by cos 20 is tan 20. And here, when you want to divide a number divided by a fraction, you know that this 0.75 will go up. That will be tan 20 equal to 1.96 multiplied by 0.75, and this will stay on the denominator. That's how we got this one. Tan 20 equal to 1.6 times 0.75 divided by 0.2 v squared, and solve v squared from there, and that gives you 20.2, and therefore v equal to 4.5 meter per second. So when the string makes an angle 20 degrees with the horizontal, the speed of the stone is 20 meter per second. If you increase the speed, the angle will decrease. Okay, I think we have done enough number of problems in circular motion. We will revisit this in Unit 4 when we discuss rotational motion. All the terms we discussed here will be used in that section in rotational motion. Well, I'm going to stop this lesson. I think we have come to the conclusion of Unit 2. That means you must be getting ready for the test now. Unit 2 test. And make sure that you understand the practice test. You can do all the questions. And when you have done that, then go and do your test. And make sure you keep to the schedule. Do not lag behind. Always keep to the schedule. And the best thing is to always try to be ahead. Okay, I will get back to you with Unit 3 later on.